ठीक हो गया, स्टार्ट करो तो।
Okay, start. You can proceed, Kudrat. You can proceed.
Good afternoon, everyone. My name is Kudrat Ansari, and I am going to present my PPT of my thesis paper of M.Tech. The title is Performance and Emission Investigations of CI Engine using Blends of Food Waste, Mahua Oil and Corn Oil Biodiesel. First of all, I would like to say thanks to my college and management, IES College of Technology, who have given me an opportunity to pursue master degree in engineering in thermal branch. Also, I would like to say thanks to our guide, Dr. Gitesh Goga and Professor Ravindra Mohan. Okay, the aim of this objective of this present study, we will start from introduction, then we will talk about classification of the project and then experimental methodology and data analysis, resultant discussion, conclusion, and in the last we will discuss about advantage and disadvantage of that biodiesel. Now introductions. So biodiesel is domestically produced. It means it can be grown up in any forest or any farm in domestically, and it's a clean burning due to presence of the oxygen content in that, and also it is a renewable substitute for petroleum diesel because we can grow it in season to season again and again. Using biodiesel as a vehicle fuel increase energy security in place of fossil fuel if we are using, so that can be create problem near future for our upcoming generations. Also, biodiesel is renewable biodegradable fuel manufactured domestically from vegetable oil, animal fats, recycled restaurant greases, etc. Now, why we are studying? So the question comes in mind. So the first reason is to shift renewable energy sources from fossil fuel for sustainable use for in the point of view of our future upcoming generations, and it also help to reduce in global warming pollution like toxic gases emissions, carbon monoxide, nitrogen oxide, and sulfur dioxide, etc. Also, the government of India has taken the initiative to shift renewable energy sources. Since India is an oil importing country, so a large amount of GDP is expended on importing of natural oil from the Gulf countries. And also there is a major conference held in worldwide, that is COP26 and Paris Climate Deal, one of the measure of that, and also to increase the income of farmer. So this is the basic photographics of corn and biodiesel, and this is a mahua fruits and types of their crude oil and seeds. Now we will start from history of biodiesel, when it started and how it's getting progress in worldwide. So first of all, in 1890s, scientist whose name was Rudolf Diesel was the first man who invented the diesel engine. So also when we invented diesel engine, so basically when we invented diesel engine, so we have to also invent a biodiesel. In 1970s and 1990s, there is a agency called EPA, which is situated in America, has given suggested to oil should be free from sulfur dioxide and carbon monoxide and nitrogen oxides. In 1998, allowed the production of biofuel at a commercial level, and in 2010, the production of biofuels reached up to 105 billion liters worldwide. And in 2011, the European Union was the largest one to use biodiesels. Now, types of biofuels. Generally, biofuels are three types. There is a first generation biofuels, second generation biofuels, and the third generation biofuels. The first generation biofuels is made from the sugar, starch, vegetables, or generally in the crops we are we are using to in eating purpose. And the second generation biofuels made from non-edible plants materials like mahua, jatropha, etc. And the third generation biofuel are made from algae and microbes which are present in sea waves and any other areas. Now this is the common types of biofuel: bioethanol, biomethanol, biodiesel, and biogases. Now this is the standard biodiesel cycle. The sunlight coming to the earth and the crop are using photosynthesis, and after they growing up, the seeds are extracted from there, and that is converted to crude oil, and then after refining, it will get it for transesterification with the reaction with alcohol. And then there is a two products come out. So one is a glycerol, and remaining is biodiesel. So again, glycerol is sent to the food industry or cosmetic industry to making some other substances, and now biodiesel sent to fuel pump and they supply. Again, the vehicle is release energy and carbon dioxide, which are again used for photosynthesis by the plant. Now, production of biofuels. So first of all, we will talk about transesterification of corn oil. Since in seeds oil there is already presence of triglyceride presence in corn seed oil, so we given a reaction with alcohol as a base catalyst, and after 1 hour it is get a mixture of fatty acid, methyl ester and glycerol, separate one. So 6.75 gram of potassium hydroxide dissolved into 20 ml of methanol, and then after a time is forming a potassium methoxide solution. So this reaction generally occur in 3 stages. In first stage there is a 2 immiscible phases where the soluble reaction is very slow at the first stage, and in the second stage it converted into fatty acid, methyl ester and glycerol, a separate one. And the third stage it converted into turbid orange brown color, and after 5 to 10 minutes it's become a transparent brown color, and the upper layer, which is known as pure methyl ester, and the lower layer become pure glycerol. So we have separated to them, and then now in the final we have to give a heat of 100 degrees centigrade to remove the water content in the diesel, and then finally biodiesel obtained. So this is a transesterification process of mahua oil. We have taken 4 container we have purchased from the local market, and the mixture of blended fuel taken as a B05, which means the 5% of mahua blend and remaining 90% are pure diesel, and B10 means 10% of blended biodiesel by mahua oil, and 90% is natural diesel, and similarly the B15 and B20 is same as. Now this is a specification of engine which are taking to use in testing. This is the engine layout setup where the dynamometer is used, the mahua biodiesel diethyl ester, and we are measuring from DAQ system with the help of amplifier. Now the lipid extraction of biodiesel from food waste. In India, a huge amount of food waste occurring every day. If you talk about the average from per person, it is a 50 kg per person food wasting in India. Now the food wasted is converted to bio oil by pyrolysis. Now there's a configuration bioethanol is converted after the fermentation of carbohydrate rich portion. So biodiesel is often. Now physical chemical properties of diesel and mahua biodiesel blends. So again we have taken the composition measuring devices. There's a HSD, means high sulfur diesel. It is also called a natural diesel. Then B5 means 5% blend at 95% diesel, and B10, B15 similarly. And we measure its viscosity with the help of capillary tube at a high temperature, and the standard was taken ASTMD 445, and density and high caloric value also measure, which is given in the table. Okay, this is the physiochemical properties for corn oil seeds, methyl ester, blended biofuel, and the conventional diesel. These all are, again we have taken the parameters is a gross calorific value, cloud point as percentage, and flash point as for turbine and different point, CVT 100% blend and 30% blend, 50% blend, 70% blends, and D100 means diesel natural 100%. So all the graph in this table is given. Now the comparison of food waste biodiesel properties with ASTM standard, EN and IES standard. So we have taken properties like density, kinematic viscosity, power point, cloud point, flash point, etc. with the different standard measurement as a ASTM D75 and obtained value we are given in the table. Now we will discuss about result and discussion. So first of all, we talk about corn oil biodiesel. The variation of brake power to change to load with different blends of biofuels. So we can see here in the graph, there is x-axis shows the load percentage and y-axis shows the brake power in kilowatt. So we can see from when the load is increasing from 0 to 100%. So we can see that the line which is orange color and in between triangle shape is a 70% blend of corn oil. So this having the lowest one when we talk about brake power, but if you talk about the CVT 30%, which is a blue line having a dotted, initially there is some common one, but when the load is increasing from 75 to 100%, it can clearly show that the 30% blend of corn oil having the highest brake power. Now next, we will talk about the variation of brake thermal efficiency to change in load with different biofuel blends. So again, here x-axis shows the load percentage and y-axis shows the brake thermal efficiency percentage. Again, load is started from 0 to 100%. So we can see up to 50% is almost 30% almost every one having the same brake thermal efficiency, but when the load is increasing from 50% to above 70% or 100% above, so we can see the blue line having square shape is a CVT 30%. So when the load is increasing rapidly from 75 to 100%, we can see there is a quite high thermal efficiency for 30% blend of fuel with compared to all of the blended or natural diesel. This is a natural diesel having a line with crosses, and CBT 30 for orange color and red for CBT 50%. So again, here fulfill the criteria for obtaining a higher brake thermal efficiency is a CBT 30%. Now let's move on from variation of brake specific fuel consumption to change in load with the different biofuel blends. So again here, when the load is x-axis present the load percentage and y-axis present the brake specific fuel consumption rate. So again, when the load is increased, load was at the 25%. So there was almost it is same for fuel consumption of every blend or natural diesel. But when the load is increasing from 25 to 50 or 75-100%, so we can see at a 50% load, there is a minimum fuel consumption for natural diesel. We can see here there is a minimum up to 50-degree temperature, 50 degree of load, 50% of load. This is a natural diesel having the lowest fuel consumption, but the load is increasing up to 75 and 100%. So we can finally that the CBT 30, which having the 30% blend of corn oil, having the lowest fuel consumption with compared to all of them. So at the 100% of load, again, you have to fulfill the criteria for obtaining the minimum fuel consumption. Is a CBT fulfill that. Now let's move on a variation of brake specific energy consumption to change in load with different biofuel blends. Now again here, x-axis shows the load percentage and y-axis shows the brake specific energy consumption, okay, which blended fuels are consuming more consumption of energy. So again, at the 25% of load, almost every are at the same level, but natural diesel having some quite higher consumption of energy. And the green line, blue line, which having the CBT 30% is from starting to end of them in up to 100%, is having the lowest energy consumption rate with compared to all of the blended fuel or natural diesel. So again, here the for obtaining the minimum energy consumption fuels, again the CBT 30% blend having fulfilled the criteria. Now variation of hydrocarbon emission to change in load with the different biofuel blends. So again, you can see here x-axis shows the load percentage and y-axis shows the hydrocarbon emission in parts per million. When the load is increasing from 0 to 100%, we can see at the 0% load, the hydrocarbon emission was quite higher with the natural diesel, and it's always higher for approximate all the load percentage. We can see clearly here. Sorry for that, light has gone, I think. After the load is increasing 100%, so we can see the CBT 70% of blend, which is showing the cross lines with that having the highest having the lowest emission of hydrocarbons. So and that at that scenario, when we will talk about the hydrocarbon emission point of view, so here the CBT 70% blends fuel having fulfilled the criteria to reduction in hydrocarbon emission. Now there is a highest for natural diesel. Now we'll talk about variation of carbon monoxide to change the load with different biofuels. So again, we can say here the load percentage shows the x-axis and y-axis shows the carbon monoxide emissions. Now we can see at the 0% of load, there is a minimum for CBT 70% of blend and higher for natural diesel. When the load is increasing from 25, 50 to 100%, there is always the carbon monoxide emission is lower for 70% of blend of corn oil, and there is always higher for the natural diesel. So again, as a carbon monoxide emission point of view, if we talk about the reduction, so we have to use 70% blends of carbon corn oil biodiesel. Now variation of smoke emission to change in load with the different biofuel blends. So again, we can see in the figure, the x-axis shows the load percentage and y-axis shows the smoke capacity percentage. When the load is increasing from 0 to 100%, it shows at the 0% also, it's always higher for natural diesel smoke variation with compared to all blended diesel. But if you talk about the 30% blend, we can clearly see here having the lowest at the initial stages. But after when the 30% or 40%, we have increased the load percentage. So it is a low but natural diesel, but is a higher for CBT 50 and CBT 70%. So in that also, when the load is increasing from 50 to 100%, so 70% of blend for my biodiesel having very less smoke emission with compared to all of them. Okay, now result of discussion for Mahua oil biodiesel. Here x-axis shows the BMEP information, and this is a brake thermal efficiency. When the BMEP increased from 0.9 to 4.9, we can see in the figure is that initially at a 0.9, the brake thermal efficiency for almost every blended fuel and natural fuel having at the same level. But when the load, when the pressure increases from 0.9 to 4.9, so you can see that for higher brake thermal efficiency, we have the yellow line shows for the higher one compared to one. So that is the AD10. AD20 means the 20% of Mahua oil and remaining 80% are natural diesel having fulfilled the criteria for obtaining the brake thermal efficiency higher. Now we'll talk about brake specific fuel consumption variations. The x-axis shows the BMEP pressure and the y-axis shows the BSFC, brake specific fuel consumption. For this that when the pressure was 0.9, at this time almost everyone having the same fuel consumption rate, but when the pressure increases, we can show clearly that there is a lowest fuel consumption rate of 80-20% blends of motor diesel, having shown in yellow color, we can see easily. Now carbon monoxide variation in motor diesel. Again here x-axis shows the BMEP pressure and carbon monoxide emission in the y-axis. At the initial stage, there is a lowest for carbon monoxide emission is for 10%. 10% of blend having with a less with compared to all of them. But when the load pressure is increased up to 2.9, so always at the time also has the 80-10 has the minimum carbon monoxide emission. But when the pressure increases to 4.9 bar, we can see the carbon monoxide emission for HSD means high sulfur diesel having the more with compared to all of them, and there is a lowest for 80-10% blend, means 10% of motor oil and remaining 90% is natural diesel, having the lowest carbon monoxide emissions. Now exhaust gas temperature variation. So again here x-axis shows the BMEP pressure and y-axis shows the exhaust gas temperature. So initially as a 0.9 BMEP bar, we can see almost every blended fuel having the same gas temperature variation, exhaust gas temperature variation. But when the pressure increases, we can see the purple color having the rectangle shape is be 15% of blend having a more gas temperature, and there is a 20% of blend having the minimum with compared to all of them. So again here fulfill the blended diesel of 20% of motor oil has fulfilled the criteria to reduction in exhaust gas temperature. Now smoke variation. X-axis shows the BMEP pressure and y-axis shows smoke capacity. So when the pressure is increased from 0.9 bar to 4.9 bar up to 2.9 bar, it shows almost everyone having similar smoke variation. But when the load is pressure increased from 3.5 bar, 3.4 bar to 4.9 bar, we can see easily here for 80-10% blend having the lowest smoke variation. And HSD means the natural diesel, which also called the high sulfur diesel, having the highest smoke variation with compared to all of them. So that's why here again fulfill the criteria for 80-10, and just above that 80-20 also 80-20% blend having also the just quite more than with compared to 80-10 blended. Now nitrogen oxide variations. Again x-axis shows the BMEP pressure in bar, and there is nitrogen oxide in part per million. So at the pressure of 0.9, again there is a similar nitrogen oxide variation with compared to all blended. But when the pressure is increasing up to 4.9, we can see the 80-20% of blends having the lowest nitrogen oxide emission with compared to all of them, and the HSD natural diesel having the highest nitrogen oxide emission with compared to all of them. Now conclusion. Based on the result obtained from previous section, main conclusion have been below. The CBT 30% in corn oil biodiesel having 2.78 higher than conventional diesel if you talk about brake power efficiency. Now the brake thermal efficiency for 30% blend of corn oil found at the 15% higher than conventional diesel. The brake specific fuel consumption for corn oil 30% blend is 11.9 and lower than conventional diesel. In case of CBT 70 and 50, the brake specific fuel consumption is 6.7 and etc., which are shown in that. The brake specific energy consumption, if you talk about, so there is a CBT 30% is observed the closer to conventional diesel D100 at a full load, but in case of 70% to 50%, the brake specific energy consumption is 5% or 7% higher than conventional diesel. The emission level of carbon monoxide and hydrocarbon for CBT 70% is decreased by 48% or 64%. The smoke capacity for 30% blend of corn oil is 85% less with compared to natural diesel. So finally, it concluded that the 30% blends of corn oil biodiesel having a fuel without any modification runs smoothly in compression ignition diesel. And if you talk about the brake thermal efficiency for 80-20% at full load is found to be higher compared to all of them. The brake specific fuel consumption is lower for 20 blend with compared to all mobile blend biodiesel. Carbon emission also the less for 8010, but there is a quite high with the, compared to 8010 for 8020. So again, exhaust gas temperature is less for 8020 blends with compared to all mobile blended. Nitrogen oxide emission very less for 8020 with compared to all mobile blend. Overall, 8020 mobile blends are very useful to make biodiesel. Now we'll talk about advantage and disadvantage of corn oil biodiesel. Advantage that it is renewable, that we can produce, we can grow it every seasons, and it has eco-friendly due to emission of less toxic gases which compared to the natural gases, and good for environment. Now there is a less pollution with compared to conventional. Easily available and easy to produce, doubling in income of farmers. Transportation cost is less because if we talk about natural diesel, we have to transport from the Gulf countries.
अरे सर वो म्यूट करने के लिए बोल रहा हूँ, म्यूट कर लो, आपके बैकग्राउंड से आवाज आ रही
transportation
है.
cost, overall fuel price reduced, and employment generation is also occur when they will install the plant of biodiesels. Now disadvantage is that there might be possible in near future for food crisis, and also since a corn crop is a water uses, it use a lot of waters, and also it use a lot of fertilizers, so maybe it will be for high cost of productions. It is not suitable for high speed engine because for high speed engine it required a high amount of energy. It is also challenging in winter season due to presence of edible oil. It can be might be some freezing problems. And now advantage and disadvantage of mahua oil biodiesel. Advantage is that it is easily available in Indian forest. There is a less to care, and water consumption is also very less. There is a more productivity. It means average mahua tree can produce 30 to 200 kg of seeds in every year. This is a cheap in market. If you go for purchase of mahua oil substances like fruits or seeds, it's a very cheap with compared to all of them. It's a helping in earning for rural poor who is residing in the forest area. It is also renewable energy sources because in again every season we will get from that. There is a no food crisis for using mahua as a biodiesel. Now disadvantage that it is a seasonal tree, we cannot get every time in that. This is a dense tree. It's reduced the productivity of farm under a mahua tree. If suppose there is a mahua tree in any farm of the farmer, so it will reduce the production because there is a dense tree, so the sunlight does not incident properly in the surface of this farm, so in the lower crops will not cannot take proper photosynthesis, so that's the disadvantage. Thank you. This is my presentation by me, Kudran Sari, M.Tech person, Science College Technology. Thank you.
Okay, Kudrat.
Yes, sir.
Yes, Kudrat.
So I have some questions for you. First is that as the world is going to the electric vehicles very fastly, so why we are wasting the time this topic of alternative fuels? Hello.
ऐसा वार्निंग रिजल्ट आएंगे ना अप्रैल में तो रिजल्ट आने वाला
Just hold on. हाँ सर बोलिए.
लेकिन अब ऐसा नहीं
Hello.
इस सब्जेक्ट का अगर
Kudrat, can you hear me?
हाँ sir, here. Yes, I can hear you.
My question is that the world is moving towards the electric vehicles very fastly. So why we are wasting our time towards this topic of alternative fuels, as continuously the world is moving towards the alternative electric vehicles in a very rapid manner.
Sir, we have seen in the recent news that in this summer season there is a drawback for battery electricity bike because they got blasted. Sometimes I have seen in the news, so that is also the major concern with the electrical vehicle. But in this world, we cannot rapidly move to an electrical vehicle. We have to take also substances for natural in place of biodiesel. So that's why also, sir, I think that might be possible to also to invent in some biodiesel in place of fossil fuel.
Okay, and another reason maybe that the batteries of the electric vehicles, the e-waste will, a lot of e-waste will be generated.
Oh.
by the batteries of these electric vehicles, and that will pollute the environment furthermore.
Yes,
That may
sir.
be
It is
the
also challenging.
and yeah. That is also a big challenge.
And
Next
And
question is that
so,
you have
hello,
discussed about ASTM standards.
Mhm.
hello.
So, what is the full form of ASTM? Can you tell me?
Sorry, sir. At the time I forget it.
Okay, so you should remember that is American Standards for Testing Materials.
Testing and materials. Yeah.
Yeah, American Standards for Testing Materials.
डॉक्टर
And I
डॉक्टर
also want to give
जस्ट
something.
कुदरत डॉक्टर अनीता सोनी मैम कुछ पूछना चाह रहे हैं आपसे हाँ
Okay, sir.
बताइए यस मैम यस मैम
Yeah, and Tari, tell me one thing, that electric, that battery will discharge very rapidly. बहुत जल्दी वो discharge हो जाती है. For that also you have to think the alternative of that.
Good evening, ma'am. First of all,
Good evening.
ma'am, if you'll talk about to recharging a battery in electric vehicles, so in India there is a huge population for purchasing the electric vehicles. So there is a major challenge for installing in every point, every corner of India to install the charging point for electric vehicles. So that will also major challenge for us. But
In spite of that, if we increase the capacity in that battery itself, then
ma'am, at this time,
might be possible.
ma'am, battery, if you'll taking at the news, so the lithium ion battery having some more capacity to hold and store the electric charges. So at this place, we can convert it from plastic battery to lithium ion battery for
Okay.
long life cycles and charging
Which
points.
material is best for charging?
Lithium ion
Which
battery.
material you are using for charging?
Lithium ion.
Liquid?
Lithium ion.
Okay. Okay.
ओके ओके
Thank you.
मनमोहन सर आप कुछ पूछिए
Kudrat, I have one more question.
Yes, sir.
यस सर
You have discussed about the emissions of oxides of nitrogen, NOx.
Okay.
Can you explain how NOx emissions are formed
Nitrogen
in
oxide
an
is,
engine?
sir, when in engine cylinder, when there is an incomplete combustion of fuels, can generate the smoke and nitrogen oxide emissions.
This is not the correct answer. CO emissions are produced due to incomplete combustion of the fuel, but oxides of nitrogen, NOx emissions are not produced due to incomplete combustion of fuel. Because as you can see with the increase of rate of biodiesel, the NOx emissions increase.
Okay.
That is not due to the incomplete combustion of fuel. That is due to the
Due to the
reaction of oxygen and nitrogen at high temperature inside the engine cylinder. Because the temperature inside the do you know what is the temperature of inside the engine cylinder?
temperature inside the cylinder. Yes, sir. When the compression goes to top bottom center.
How much is the temperature inside the engine cylinder? This is what I am asking.
आफ्टर द कंबशंस
Yeah, after combustion process, how much is the temperature of the engine cylinder? This is what I am asking.
Sir, approximate 450 degrees centigrade to 600 degrees centigrade.
No, it is a rather it is a 800 to 1200 degrees Celsius. So it is a it is very much a high temperature, and at this temperature, when nitrogen from the fuel and oxygen reacts together, then oxides of nitrogen are formed.
Performed.
Yeah, these are formed accordingly. And due to the fact that the biodiesel has more oxygen content, the nitrogen gets more oxygen to react with the
Inside the cylinder. With the high temperature.
inside the cylinder, and that's why more NOx emissions are formed. This is the correct answer. Okay.
Okay. Sir.
After developing, what is the cost of this product?
Manmohan sir,
Yes,
Sorry,
sir.
sir.
Manmohan sir. Yes, sir.
Yes.
Manmohan
Just one question I'm asking you.
Okay,
And
sir.
after developing, what is the cost of this product?
Sorry, sir, your voice, I cannot hear you. Could you please repeat it again?
Okay. I'm
Manmohan
asking
sir,
you,
आप
what is the cost of this product?
What will be
the cost of the product
Cost of the product.
the cost of
तो
the
आपका
product? Definitely it will be
bio
lower than natural diesel, sir.
What is the lower cost? Just I'm asking. That's why I'm asking you.
Lower cost, if you will taking a natural diesel at the time, there is a 100 per liter, so it could be some 80 rupees per liter around.
So, and mileage wise, what is the difference?
Mileage was, we will see about the brake thermal efficiency, what is the inside the cylinder heat is producing. So mileage quite less with the natural diesel because there is a high percentage of sulfur dioxide.
Okay.
Okay, sir.
okay.
one more suggestion, Kudrat, that you should also add the research papers that you have got published or that have been accepted in your PPT.
Okay, sir. After the completion of this meeting, after.
Yeah. For the final presentation, you have to add those also.
Okay.
Okay. Any question apart from that?
Ma'am, principal ma'am.
That's it from my side.
Dr. Gupta sir, any question? Dr. Gupta sir.
Dr. Dhirendra Gupta, sir.
No.
Okay,
Okay.
then we should.
मनमोहन सर क्लोज करते हैं फिर.
बिल्कुल. Okay.
ओके मैम कुछ क्वेश्चन करेंगे क्या?
चलिए क्लोज कर दीजिए.
नहीं ठीक.
ओके 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 थैंक यू मैम.
Thank you, sir. Thank you all of you.
लीव कर जाइए आप.
Thank you, sir. Thank you all of you.